to go to the Bucharest city, and there are some intermediate city which are available, and these values which are associated with every edge will telling us that it is a cost to reach from one city to another city. This is how we can reach from one city to another city and find out the path cost at last. So from the Arad, we have three cities: Zerend, Timisoara, and Sibui. So we can go from this state to these three states by performing the actions, right? What is the action? Right now I am in Arad. When I'll perform from Arad to Zerend with the cost 75, I'll reach in Zerend. So in Zerend is my state right now. And after getting into the state, I'll just find out whether the state is a goal state or not, right? So this is how I'll have this action and this transition model and the states. So this is all about those five things: initial state, action, transition model, then we have goal state and the path cost. The example we have seen, which is our vacuum cleaner, that how we can define the problem, and after defining the problem we'll got a graph. That graph is called state space graph. This state space graph will give us the possible number of states which can be done by performing some action. Okay, so these are nothing but that is nothing but state space. So after solving the state space, any of these can be the goal. So we have two goal state here. What is a goal? Goal is to reach the to clean both the rooms is my goal. So this will be the goal or this will be the goal, right? So in any of the goal we have to reach from the initial state. These two are the initial state where from where we have to reach any of the goal. This is the sequence that will get it by performing the transition function, and the action will be performed accordingly and will reach the goal by performing this state space diagram. We have some toy problem that we have also seen, that is called 8 puzzle problem. We have some real world problem that I told you about. There is some searching solution, that how we can search the solution. So for searching, we need to have this state space. These are called all state space. Now here we have two things. One thing is what are the state that we have already explored, and what are the state that we need to explore. So the state which need to explore are called frontier node, and the state which has already been explored comes under explored list. Okay, so that we know, and based on that we have some searching solutions. So these searching solutions is we have some searching solution. Let's go to the searching solution. So these searching solutions that we have seen comes under uninformed search strategies. That is also called blind search, where we doesn't have the additional information about the search. We have what we have. We have the initial state, we have the goal state, and we have the transition function. So all these three things are there, and based on that we'll perform the search to reach the goal. Okay, we don't have other information. That comes under uninformed search. So the first searching algorithm that we have learned is called breadth first search, where a node will be searched based on the breadth. Breadth means your depth of that particular graph. So A is the initial state. What is the breadth in that particular one? So one depth is, let's say, B and C. So B and C we have to explore. Then we'll go to the next depth and explore all. So we'll go to next depth, that is D, E, F, G, that we are exploring. In that way, we are learning for the goal, if the goal is there or not, right? So when from A we'll go to B and C. So we'll go first B, find out B is goal or not. If not, we'll go to C, C is goal or not. Okay, so then we'll go to D, D is goal or not. Then we'll go to E, E is goal or not. Then we'll go to F, and then we'll go to G. In that way, we'll reach to the solution in the breadth first search. Now, what happened in there is uniform cost search. We'll see that later on. After that, we'll go to the depth first search, and the depth first search will go to one depth at a time. So here we are in depth 0 right now. This is a goal? No, it is not a goal. Then we have to explore the depth. Now, after exploring the depth, B and C, we'll go to the B in one depth. B is the goal? No. Then we'll go to the depth of the B, that is D and E. D is the goal? No, D is not the goal. Then we'll go again to the depth of the D, that is H and I. H is the goal? No. Then we'll go to the depth of the H. The depth of the H is not available. Then we'll go to the I and go to the depth of I. Depth of I is not available. Then we'll backtrack it into D again. D is already visited. Then we'll go to a backtrack. B. B is already visited. Then we'll backtrack to E. Now we'll come to E and explore E again. In that way, the depth first search work. So if you'll find out uh, the number of state space, so number of state space here is less at a particular time. Here the number of state space is more at a time. So here all the sequence we have to store somewhere. Here we have to store very less number of values at a time. So space required here in depth first search is less. Okay. Uniform cost search we'll see at very last. Then we have depth limited search, where we'll define the limit of the depth, that in that particular depth we have to go. Like in the depth first search, we doesn't have this constraint in what depth we have to search. But in the depth limited search, we have some limit, that in that particular limit we have to go, otherwise we have to backtrack again and explore another branch of it up to that depth. So let's say the depth is 0, 1, 2, 3. So 3 is the depth. Now when we limit it, let's say up to 2, so we'll not go to this particular depth. We'll explore all the nodes which are in the up to depth 2, right? So that is called depth limited search, where that depth is defined earlier. Iterative deepening search, in that is again work on the depth limited search, but all the time will increase the depth. So let's say firstly we define depth 0, and in depth 0 we didn't get the goal. Then we'll go to depth 1 and iterate it. If we'll find anything on depth 1, then if we didn't find anything on depth 1, we'll go to depth 2, and again we'll explore all the nodes in the depth 2. In that way it will iterate all the time to get into the goal. So in the depth limited search, there is no guarantee that you will get the goal, or there is no guarantee that you will reach the goal. But in the iterative deepening, you have the guarantee to reach the goal. Okay, because it is increasing up to the infinite depth. That is called iterative deepening search. Then we have bidirectional search algorithm, where we'll start the searching from the initial state to the up to the final state, and from the final state up to the initial state. So we'll start the process from the initial state to the goal state, and from the goal state to the initial state, and some in between will uh, got the got the path to connect from the initial state to the goal state. So we'll start the process from start as well as from the goal state. So from the goal state, we'll go to the reverse up to the initial state, and from the initial state, we'll go to the forward up to the goal state to reach the goal. This is the comparison of all different search algorithm. Okay, and then we'll talk about uniform cost search. Now, what happened in the uniform cost search? We'll use the Disgastra algorithm for that. What is the Disgastra algorithm that we have seen earlier, and you know that? I'm just telling you that with this particular example, how this uniform cost search work. With this slide only, okay? And later on, we'll see in the board that how we can solve a uniform cost search algorithms. Now here, this G is the goal state, A is the initial state. These ages values are telling us the path cost, okay? Now, in the uniform cost search, let's say we are starting with A. So A is, we are putting into the frontier list, and then we are exploring it. When we are exploring A, it will explore B and C. So A has been explored, so it will come into the explored list. So whatever the list is, I am marking it as a right. Okay, so now A has been explored. Now we have B and C in my frontier list. Now the B and C, because we are using uniform cost search, so for the frontier we have to make a queue that is called priority queue based on the path cost. So here, what is the path cost from reaching from here to here? It is 3. And what is the path cost from reaching to here is 7. So whose path cost is less? So path cost of C is less. So now what we'll do is we'll explore C. Okay. So now we are going to explore C. Once we explore C, so we have the value D and B, right? So from C, to explore B, what is the path cost we have? So it is 3 and 2, that is 5. And what is the path cost to reach D? That is 3 and 9, that is 11. Sorry, 12. So which one we have to explore here based on the priority queue? So here we have B and D in the frontier list, because B, to reach B from A, we are having what? The value 5. So we'll explore B again, right? So once we find out that this is the frontier node to explore, then B has to be explored. Now once we'll explore B, we already know that C has been explored, so we doesn't have to explore it again. We have only one option, that is E. So how much cost it has been taken to reach E? That is 2, that is 5, and then 6 is 11. So 11 will be the cost here. Now E is the only node which are having less, because here it is 12, right? So we'll not go into that direction because the cost is here 12. 9 plus 3 is 12, and here it will be 11. So we'll explore E again. Now when we'll explore E, so what are the value we have? We have D, we have F, and we have G, right? So from here we will find out the path cost. That is, here it is 11. 11 plus 1 is 12. Here it is 11. 11 plus 3 is 14. And this 11 plus 12 is 11 plus 2 is 13. Now here if we'll find out, it is of less cost. It is 12. So now we'll explore G. Once you'll explore G, you'll find out that G is your goal node. So what is the if we'll find out the goal node, so from the goal node, we'll reach to the initial node to get the path. So what is the path? Path is this: A to C, C to B, B to E, and E to G is your path to reach the goal from with the help of uniform cost search. Okay, so that we have seen in the slide, we'll see in the board also in the later on sessions. So up to that, we have actually learned in our last class.